What if I told you a tornado starts with nothing more than warm air and a little spin? Tornadoes form when warm, moist air near the ground meets cold, dry air above. This creates instability. Add wind shear, when wind changes speed or direction with height, and the air begins to rotate. If this rotation tightens and stretches upward, a tornado can form. It's nature's most violent spin cycle. Ever seen a thunderstorm explode into life? That's convection at work. When the sun heats the Earth's surface, warm air rises. If it's humid, that air cools and condenses into towering cumulonimbus clouds. Inside, updrafts and downdrafts clash, creating lightning, thunder, and sometimes hail. The stronger the updraft, the more intense the storm. It's a vertical battle of air masses, and the sky is the arena. Hurricanes are heat engines powered by warm ocean water. When sea surface temperatures rise above 26.5 degrees Celsius, 80 degrees, evaporation fuels massive cloud systems. As air rises and condenses, it releases heat, lowering pressure and drawing in more air. This feedback loop creates a spinning monster. The eye is calm, but the eye wall? That's where winds scream at over 150 mph. Climate change is making these beasts stronger and wetter. Jet streams are high-altitude rivers of air that steer weather systems. They form where cold polar air meets warmer air from the tropics. These fast-moving winds can shift storm tracks, intensify systems, or stall them entirely. When the jet stream weakens or wobbles, thanks in part to Arctic warming, it can trap weather in place. That's how you get prolonged heat waves, floods, or cold snaps. It's the atmosphere's steering wheel. Climate change isn't just about warming, it's about disruption. As greenhouse gases trap more heat, the atmosphere holds more moisture. That means heavier rainfall, stronger storms, and longer droughts. Melting ice alters ocean currents, which in turn shift weather patterns globally. It's a domino effect. The weather you feel today is increasingly shaped by carbon emissions from decades ago. The climate system remembers everything. Ever heard of atmospheric rivers? These narrow bands of moisture in the sky can carry more water than the Amazon River. When they hit land, they unleash torrential rain and snow. California's floods, often caused by these sky rivers. As the planet warms, these systems are becoming more intense and frequent. It's like turning up the faucet on the atmosphere, and the plumbing isn't built for it. Weather forecasting has come a long way, thanks to satellites, supercomputers, and AI. Models now simulate the atmosphere in 3D, crunching billions of data points to predict storms days in advance. But chaos theory still rules. Tiny changes can lead to big differences. That's why forecasts aren't perfect. Still, understanding the science behind weather helps us prepare, adapt, and maybe even outsmart the next big storm.